Sathyabama Institute of Science and Technology.
Hi students, in continuation of what we have seen in YouTube part 1, let us continue part 2 of this YouTube, namely probability and continuous random variable distribution. Take this problem. See, in a certain city, the daily consumption of electric power is a random variable. You all know that electric consumption, electric power is a random variable. Okay, it's taken in millions of kilowatts per hour. Has been defined like this, having a PDF, f of x is equal to 1 by 9 x e power minus x by 3, defined for x greater than 0 and 0 elsewhere. What is this? This is nothing but the probability density function of the random variable. What is the random variable that we have taken here? Daily consumption of electric power, which is going to be a continuous random variable. The question is, if the city's power plant has daily capacity of 12 million of kilowatt hours, what is the probability that this power supply will be inadequate on any given day? I hope you understand the problem. This is actually an application oriented problem. They are asking when the power will be inadequate for that city on a given day, okay, where this PDF has been defined. The capacity maximum that is available is 12 million of kilowatt hours. What is the question? They are asking when this will be inadequate on a particular given day. Namely, if you write it mathematically, probability of consumption, if it is going to be 12 or more than 12, okay, more than 12, you can take it as more than 12, it is going to be inadequate. Nothing wrong in taking it as equal to 12 also. Let us take it as the power consumption, the probability of power consumption is going to be more than 12 kilowatt per hour, then it is going to be inadequate on a particular day. So what is the meaning for that? The range is going to be from 12 to infinity because the probability has been taken as greater than 12 kilowatt per hour, okay. So 12 to infinity, f of x dx, what is the function given? It's a x into exponential function, x into e power minus x by 3. This we are going to integrate with respect to x by taking the limits 12 to infinity, okay. Right. You can use Bernoulli's formula. What do you mean by Bernoulli's formula? You have to apply this u dv, the alternate formula for u dv, okay. You have to take this x constant, integrate this e power minus x by 3, it's going to be e power minus x by 3 by minus 1 by 3, that can be taken like this, then minus differentiation of x is going to be 1, and then again integrating this, minus of minus becomes plus 3 square. If it goes to the numerator, it's going to be like e power minus x by 3 by 1 by 3 square, that is nothing but 9 e power minus x by 3. I repeat again, this I am trying to use by doing by Bernoulli's formula, x constant, u constant, integrate v, this is going to be v, the exponential function integration is e power minus x by 3 divided by minus 1 by 3, that is taken like this, then minus u dash, this is 1. Why? Differentiation of x, differentiation of u, namely x with respect to x is 1, and integration of this gives you minus of minus plus, and denominator is going to be 1 by 9 square, which is taken like this over the limits 12 to infinity, right. As you all know very well, e power minus infinity, as you all know very well, e power minus infinity is 0. So upper limit is 0, lower limit is minus of minus plus 12 into 3, 36 e power minus 12 by 3, right. Upper limit is 0, minus, lower limit already minus, one more minus, it's going to be 3 into 12, 36 e power minus 12 by 3. Then minus, this is there, again e power minus infinity is 0, lower upper limit is 0, lower limit you have got minus 9 e power minus 4 again. Let me simplify. If you simplify now, it's going to be 45 e power minus 4 by 9. I hope it is clear. This is minus of minus. So 36 plus 9 is going to be 45 e power minus 4 by 9. You can use your calculator and find what is the value of this e power minus 4, product 45 by 9. So you can find that the probability that the inadequate power supply going to be there on that particular day is going to be 0.0916 approximately. That means it's going to be very, very less. That means the power supply is going to be available. The chance of not getting the power supply on that particular day, if it is going to be for more than 12 million kilowatt hours is going to be this probability 0.09. Okay. See the next problem. Actually, again an interesting problem. We are going to find the standard deviation, variance and mean. Given the function, the probability density function has been given. The random variable is x, defined like this. The question is, calculate the mean, variance and standard deviation. See how it's going to be. You all know very well. Mean is integral minus infinity plus infinity x f of x dx. That's by definition of mean, calculating mean, expectation of x are mean. And the limits that has been defined here, see, it has been taken as 0 to 1, piecewise continuous, 0 to 1, 1 to 2, 0 otherwise. I am going to take it as 0 to 1, where the function is going to be taken as x. 0 to 1, the function is being taken as x. Second interval, 1 to 2, the function is going to be 2 minus x. Then, other than this, other than 0 to 1, 1 to 2, they have said that we have to take the function as 0. So, I will not bother about that. I will be concentrating only over the interval 0 to 1 and then 1 to 2. Function has been taken. Now, we have to integrate. As you all know, integration of x square is x cube by 3 and this one it is 2 x square by 2. You can cancel 2 and this one is x cube by 3. Interval, first one interval is 0 to 1. The second one interval is 1 to 2. And substituting now, the upper and lower limit, we will be getting 1 by 3 minus 0, lower limit is 0 and here the upper limit is 2, lower limit is 1 and here it is, it's going to be 4 minus, see this one, 4 minus 1, okay, and this one it is 2 cube, 8 by 3, 8 by 3 minus 1 by 3. On simplifying, you get the answer as 1. So, mean is exactly 1, average expectation of x for this random variable x is going to be 1. Now, let us move on to the variance. How do you calculate this variance? What is the formula for variance? How do you write variance as? Before finding variance, before going to the variance, you are supposed to get the value of expectation of x square, isn't it? Variance is expectation of x square minus expectation of x the whole square. So, this is required if you want to do the part variance. For that, first you calculate expectation of x square. What is the formula for expectation of x square? Instead of x, there in mean we take x, whereas in expectation of x square you take x square f of x. Let me further simplify. 0 to 1. I told you already, we are going to concentrate only over 0 to 1 and then 1 to 2. What is the function here? First interval x. Function over the second interval 2 minus x. Let me integrate this as like what we have been doing previously. X power 4 by 4 because it is x cube. This one 2x cube by 3 and this one it is minus x cube already. So, integration is going to be x power 4 by 4. Limits are the first one 0 to 1, the second part it is 1 to 2. Let me go for the upper and lower limits. Simple, 1 by 4 minus 0 and this one you can simplify. See, here it is 2 cube 8, 8 by 3, okay. So, you can simplify, you can substitute the upper and lower limit, simplify this and get the answer as approximately 1.1667. That is nothing but expectation of x square. What is the need for this expectation of x square? To calculate the variance. That is what we want. What is variance of x? They call it as capital V of x. Sometimes you can even denote it as sigma square. Sigma square is nothing but the variance. I told you already, the formula is expectation of x square. That is why we have calculated this. Minus expectation of x the whole square. What is that? 1.1667 approximately. That is what we have got for expectation of x square minus 1 square. The answer is 0.1667. That is it. We have calculated the variance. So, started with mean, then we want to calculate the variance for which we have calculated expectation of x square and now I have substituted here the respective places and got the answer for variance as 0.1667. And then finally, the third part is what is the standard deviation? Here mistake there, it should be sigma equal to root of variance. So, what is variance? 0.1667, that is it. 0.4083 is going to be the answer for standard deviation. Okay. Now, let us move on to the next problem. See this problem, again x has been taken as a continuous random variable with the following probability density function. The question is, calculate the mean and variance of x, alright. See, the interval is 1 to 2. You are going to concentrate only over this interval 1 to 2, alright. So, mean, average, the value is 1 to 2 x into f of x dx. And I think you can complete this integration. It's going to be 2 out, x into x minus 1 integration. After substituting the upper and lower limit, you get the answer as 5 by 3. That is nothing but expectation of x. Next, it is variance. As you all know that variance is defined, variance, if you want to find variance, you have to calculate expectation of x square. Expectation of x square, the difference between this expectation of x and x square is, you are going to replace x by x square and then substitute this function f of x and integrate this, and the answer is going to be 17 by 6. That is for expectation of x square. The need for calculating this expectation of x square is to find the variance. So, what is variance? Variance is defined as expectation of x square minus this mean square. Mean is nothing but mu or expectation of x, it is all same. Substituting the values, it is 17 by 6 minus 5 by 3 the whole square. On simplifying, you can use your calculator and even get the answer in terms of decimals. It's going to be 1 by 18. So, the answer for variance of this problem is 1 by 18, right. Let us move on to the next problem, where this is a different idea, where you have been given this probability density function. Instead of f of x, they have taken it as p of x, nothing wrong in it. F of x, p of x, it all represents the same. So, the question is, what is the probability that x values, a random variable x, lies between 1 and 2? The second part is, what is the probability that you can take this as small p of x and this as capital P of x, like that you can have some difference. What is the probability that the random variable x is lesser than or equal to 2? And the third question is, what is the probability that the random variable x is greater than 1? These are the three things that we are going to calculate in this problem, where you have been given this PDF, which is kx square, interval is -3 to +3. First of all, you have to know that we have to find the value of k. If you find k, then only you can go for this 3 subdivisions. How to find the value of k? Think. It has been given, the function has been given as a probability density function. Okay, it has been defined as a probability density function. That means the condition that must be satisfied for it to be a probability density function is integral -infinity plus infinity p of x dx is equal to 1. I have taken the function as capital P of x or small p of x, does not matter. So, this is the condition that must be satisfied for the function to be a probability density function, shortly PDF. So, but I am going to concentrate only over the interval -3 to +3, because elsewhere it is all going to be, the function is going to be 0 completely. So, concentrate only over the interval -3 to +3. What is our job? We have to find the value of k. Okay, k being taken out, what is integration of x square? X cube by 3, lower limit is there -3 and upper limit is there 3, and that is equal to 1. This is in order to find the value of k, where it is given as a probability density function. It satisfies the probability density function. Simplify this, get the value of k. What is the upper limit? 3 cube minus lower limit is -3 the whole cube. So, it is all simplified. You can get the value of k. K value is going to be 1 by 18. Okay. First you find the value of k, then only you can go for these subdivisions 1, 2 and 3. So, we have got the value of k. K is 1 by 18. Now, substitute this k value here in the function. The function changes as x square by 18, right? See here, x square by 18. What is the first question? Find the probability that the random variable x lies between 1 and 2. What is the probability answer if the random variable x is going to lie between 1 and 2? So, between 1 and 2, f of x dx, p of x dx. What is the value p of x here? Kx square. Kx square is x square by 18. Integrate this, x cube by 3, already 18 there. So, x cube by 54. Lower limit is 1, upper limit is 2. Simplify, you can easily get the answer, 7 by 54. Next, second question is, find the probability that the value of x is lesser than or equal to 2. What do you mean by lesser than or equal to 2? Maximum you can go up to, see, from -infinity to +infinity, Here they are asking what is value of x lesser than or equal to 2. Lesser than or equal to 2 means maximum you can go up to 2, but you cannot go beyond minus 3. So, 2 is going to lie between this. So, I have to calculate over the interval minus 3 to plus 2. I hope this is very clear. I repeat again, they are asking you to calculate what is the probability that the random variable x is lesser than or equal to 2. What do you mean by lesser than or equal to 2? Understand that 2 lies between minus 3 and plus 3. So, you are going to restrict yourself, your value, your answer minus 3 to plus 2, because the interval is from minus infinity plus infinity, but here the restriction is less than or equal to 2, less than or equal to 2, but starting from which point? Starting from minus 3. So, starting from minus 3 up to 2, f of x dx, same thing, but only the limits are going to change, minus 3 to 2. Start from minus 3, maximum you can go up to 2. Answer is 35 by 54. I think it is very clear. The next one, what is the probability that the random variable is more than 1? What do you mean by more than 1? More than 1. 1 lies between minus 3 plus 3, but it should be more than 1. So, start from 1, you can go maximum up to 3. Whereas the previous subdivision, the restriction is up to 2. So, start from minus 3, end up to 2. That was subdivision number 2. But whereas here, start from 1, the maximum restriction that you can take is 3. Same function, integration is same, only the limits are different. You get the answer like what I have been doing previously, upper limit minus lower limit. Answer is 13 by 27. I hope this idea is clear. Thank you. Thanks for watching the YouTube lecture number 2. Thank you.